All right, we are Group 9 and we did the Watson Wheels project. I'm Kaler.
I'm Aaron.
I'm Jarrett.
I'm Cody, and I'm the project contact.
And I'm Connell.
So starting off project motivation, we, or at least some of us in this group, are avid bikers. So we kind of wanted to do an experiment based around that. And two big things that we wanted to kind of figure out how they affect your acceleration or just speed on a bike was leg angle and weight on the bike. So, because we can't really measure acceleration, or at least we didn't really have the tools to do that this time, to measure that, we instead just took an average of the time that it takes to do a 20-yard sprint up a slight incline. So that's exactly what we did for the pilot study, as well as our main experiment, which we'll see later. But for the pilot study, we just picked one of those factors, which was seat height, leg angle. We kind of just figured out what the seat height, how that affected your leg angle, and then did arbitrary heights based on that for each person. But in this case, our height for the seat was high, which is just having your legs completely straight, 180 degrees versus standing. And then we took the time using two stopwatches and then averaged those times. And that gave us this data output that you see up at the top. So using that data, we ran our GLM, which gave us this corresponding output. And we are not so interested in the analysis of variance for this one, just because we don't really know the power of the study and if we did enough replicates. This was really just to get us this experimental error that you see down here, this S value of 0.247722. And getting that experimental error value, we are actually able to run our power analysis, which you'll see on the next slide. So running the power analysis, we chose a bunch of different versions of it just to see which one we thought would work best for our experiment. So different maximum differences, we wanted to see how each one would affect what our number of reps needed was, as well as different target powers. Based on these outputs that you can see, we kind of decided that our best bet was going to be the target power of 0.85, which with a maximum difference in reps of 0.2, and using our standard deviation of 0.247, it gave us this output of 12 reps with 108 total runs corresponding to that. We kind of thought that 0.85 was a good power, powerful enough for this study, and 0.2 seconds, we could already see that we were going to be getting something in that range for our differences with different factors. So we thought that that was definitely a big enough number as well for the differences.
We then used that data from the power analysis to conduct our main experiment. The research question for that was, does leg angle of the rider and the weight in the bike affect the time to complete a hill sprint? Once again, just like the pilot study, we had response variable of time, and we used a distance of 20 yards and measured using two stopwatches and averaging that time. We measured how long it took each person to travel those 20 yards. Our first factor was leg angle. In the pilot study, we only used two, but in this, we had three levels for that factor. Low seat height, which is 150-degree leg angle, high seat height, which was straight or 180-degree leg angle, and standing. And that leg angle was measured with our heel on the center of the pedal, and we used a protractor to measure those values. Our second factor was weight. We installed some dumbbells, 15-pound dumbbells on the back of the bike. There are three levels for that factor: 0 pounds, 15 pounds, and 30 pounds. And we use gear ties to secure them to the bike, and they're in the same position each time. For our blocking factors in the pilot study, in the power analysis, we determined that we need 12 total replicates. So we decided to do that by using 6 people, each doing it once in two separate time blocks. Of those 6 people, we had our 5 group members and then one other person who we recruited for the experiment. And yeah, we did that 2 time blocks on 2 different days. And for randomization, We attached a list of treatments and then randomized the order of the treatments. These were randomized individually for each person to ensure fair treatment. Next, our experiment procedure. So like I said before, we produced a randomized order for each person's treatments. And yeah, randomized order. And then next we set our seat height for the proper leg angle and for that weight. Set the seat height using a protractor and then secured the weight based on the treatment to the bike. We measured the 20 yards and then put tape at the start and finish to ensure that each trial was an equal distance. We started each recording by lining up the biker behind the tape line with the wheel just touching the front of the tape. Then counted down from three, three, two, one, go. And then when we said go, the biker started riding. And the people who were recording started their stopwatches. The biker then sprinted to the next tape line. And as soon as the front wheel passed the tape line, we stopped stopwatches and recorded the times. And like I said, two people recorded the times, and then we averaged those to get the most accurate possible data. And we repeated that until each person completed the treatments for one time block. So it was 9 treatments per person, 6 different people for each time block. And then we did 2 time blocks. Here's a quick video of the trial. It's about 4 to 6 seconds in duration. And here's a few pictures from our main experiment. The first picture on the left, it shows where we did our experiment. It was a hill about 3%, 4% incline, and it was 20 yards. We started at that stop sign at the bottom of the hill and ended at the tape line at the top. The middle picture, the picture of Aaron's bike, which we used for the trial. The bike was set in one gear to ensure equal trials, and the weights were secured to the rack on the back of the bike. And then we adjusted the seat height for each one. And third picture shows the protractor that we used to measure the seat height.
So here is our main experiment dot plot. On the left, we have our 2 factors, weight and seat height. And at first glance, nothing seems really obvious, but we did notice that for each weight, the lowest data always seem to be under the standing seat height. So kind of hint for maybe standing is faster. And then we ran our test for equal variance. And as you can see, there appears to be no obvious funneling or anything like that, just kind of a blob. So we determined that this will pass our test for equal variance. Next, we tested the normality of our data. And as you can see, we got a very high p-value of 0.4. And so we determined that this data could be normal, and we continued. Next, we tested for the linearity in response to weight. And this was difficult, but we determined that with only 3 levels for weight and a not so obvious line, that we couldn't say that there was a linear relationship happening here. So we decided not to put weight as a covariate in our GLM.
So here's our GLM setup for our experiment, where we have our response being average time, and our factors being, factors being our 2 factors that we tested for, weight and seat height, and our 2 blocking factors being the time block and person ID, set as random because we needed them as part of our experiment, but we weren't testing for them. Yeah, next slide. And here's our GLM information that we'll be using to calculate and stuff for like our values and stuff, and we're showing our the difference in experimental error, and it was quite close. And here's the f-test for the interaction, which is what we do first. And we can see that we have a very high or low f-test and high probability, meaning that it's very likely or that we don't have a interaction because our p-value is very high. And here's the f-test for our two factors. And we got high f values, which resulted in two low probabilities, showing that these are two factors were significant in affecting the response.
Next, we have our two key comparisons where using that we see that the weight has an effect. Adding some weight has an effect. So going from 0 pounds to 15 or 0 pounds to 30 does have an effect and is statistically significant, where going from 30 pounds to 15 pounds or 15 to 30 pounds is not as significant. Next, looking at the seat height, we see that the high seat height has the slowest time, the low seat height has middle time, and standing has the fastest time. All of those are statistically significant from each other. We see that additionally within the main effects plot with the 0 pounds to any other 15 or 30 pounds does have a significant difference, although the difference between the two 15 pound or between the 15 pound and 30 pound is not as significant. We also see from the seat height plot that the same thing with low being in the middle, high being the slowest, and standing being the fastest. So kind of looking through our data, we saw an increase in time with the addition of weight. As you added 15 or 30 pounds to the bike, it got slower. We did not find that 15 and 30 pounds are significantly different from each other, but so that just means that adding a little bit of weight to your bike will cause you to slow down, but adding a little bit additional more weight won't slow you down as much. We also saw a decrease in time going from the high seat position to low to standing. So this is a little bit different than what we would expect based on our previous experience of riding bikes, where we would expect that the low seat height, which is not as good as the high seat height, we would expect the low seat height to be slower. But because for some reason the low seat height was faster, which might have to do with the weight, might have to do with how we were riding, it is up in the air. Standing, we definitely assumed would be the fastest, as you can put the most power down. And so, yeah, from that, we see that adding weight is statistically significant and will slow down your acceleration up a hill. And additionally, going from seated to standing is also an additional jump up in speed. Thank you very much.